Bismillah ar-Rahman ar-Rahim. Now we're going to continue our explanation of algebra permutations. Okay, permutations, or shortly we can use P. Okay, expressing this permutation. Definition of permutation is number of arrangements can be done. Okay, to form a subgroup. Okay, subgroup or subset of a number of elements R. Okay, from a main set. Okay, main set whose number of elements are n. Okay, where n is greater than or equal to r, greater than or equal to 0, and r belongs to natural number, and n belongs to positive integer. Okay, then we have some rules relating permutation. Then we have these rules relating to permutations. Okay, rules. Okay, here we have first one, NBR equals n times n minus 1 times n minus 2 and so on until n minus r plus 1. Okay, for each n greater than r greater than or equal to 0. Okay, and r belongs to natural and n belongs to positive z. Okay, also we have this rule, n Pn equals a factorial of n. This equals n times n minus 1 times n minus 2 and so on until 2 and 1. Okay, we have n Br equals factorial of n divided by factorial of n minus r. Okay, as we said, factorial of n can be expressed as n factorial of n minus 1. Okay, this equals n times n minus 1 factorial of n minus 2 and so on. Okay, we have here NBR belongs to positive z. Okay, and factorial of n also belongs to positive z. Okay, here we have this rule, factorial of 0 equals factorial of 1 equals 1, and we have NB0 equals 1, and we have NB1 equals n. So we have NBR, okay, where n is greater than or equal to r equals greater than or equal to 0. Okay, and we have here n belongs to positive z. Positive z is the set contains numbers 1, 2, 3 and so on. Okay, while we have r belongs to natural. Okay, natural, we have two definition of natural. Natural may be equals z, then z positive, then we have 1, 2, 3 and so on. Another definition, we have natural means non-negative integer numbers. Then we have n or r belongs to this 0 and 1 and 2 and 3 and so on. Okay, here we have some notes or remarks about permutation. We have, as we said, NBR equals n times n minus 1 times n minus 2 and so on till n minus r plus 1. Okay, here this is a series. The first term is n, last term is n minus r plus 1, then middle term, okay, equals n plus n minus r plus 1 over 2. Then we have 2n minus r plus 1 over 2. This is the middle term of this series. Okay, we have another remark. If we have n this equals factorial of n, this equals nbn minus 1. Okay, again, if we have nbr, okay, equals factorial of r of n, factorial of n, then we have two options here. If we have this relation, then we have n equals r or n equals r minus 1. Okay, here we have another remarks or notes about permutation. If we have NBR equals NBR, then we have here n, of course, is greater than or equal to r, and we have r greater than or equal to 0, and we have n is not equal to 0. Okay, again, if we have nbx, for example, equals nby, okay, then we have here three options. X may be equals y, may be equal y. Okay, we have also x may equals n, and in this case y equals n minus 1, or y equals n, and we have here x equals n minus 1, this third option. Okay, if we have for example a factorial of x equals 1, then we have x belongs to the set 0 and 1, as the factorial of 0 is 1 and factorial of 1 is 0, is 1 as well. Okay, if we have this form, factorial of x divided by factorial of y, okay, this equals xb, okay, x minus y. Okay, okay, if we have also x b m, for example, equals y b m, then we have two options. May m equals 0, or we have x equals y. Okay, also if we have x bm equals x bm, then we have m equals 0, and also we have or we have x is greater than or equal to m. Of course, this is n and this is r. Okay, we have also the following three rules. If we have nb r divided by n minus 1 br, this equals n divided by n minus r. This relation can be memorized and applied directly, or we can prove it. Okay, another relation we have, if nbr divided by nbr minus 1, okay, this equals n minus r plus 1. And finally, if we have n plus 1 multiplied nbr, this equals n plus 1 br plus 1. Here we have this example. F factorial of n and factorial of n minus 2 and n factorial of 3 minus n represents the lengths of a triangle sides. Find the perimeter of this triangle. Okay, here we have n minus 2. This is the length of one side of a triangle. From the properties of factorial, we have n minus 2 is greater than 0, then n is greater than 2. Okay, similarly, we have n factorial of 3 minus n is the length of one side of this triangle. Then we have from the properties of the factorial, 3 minus n is greater than 0. Then we have n is greater than 3. Okay, then is less than 3, less than or equal to 3. Okay, here we have this one. Then from these two relations, we have n is greater than or equal to 2 and less than or greater or equal to 3. Then we have here n equals 2, then we have n equals 2 or n equals 3. Okay, for n equals 2, we have the sides of this triangle. We have factorial of n equals factorial of 2 equals 2. And we have n minus 2 equals factorial of 2 minus 2, then factorial of 0 equals 1. Another one, we have n factorial of 3 minus n equals 2 factorial of 3 minus 2. This is equal to, then the sides is 2 units, 1 unit, 2 units. Then the perimeter in this case equals 5 units. Okay, and you have to check that the sum of the lengths of any two sides is greater than the third one, and this is satisfied in this case when n equals 2. Okay, for n equals 3, okay, we have the sides lengths equals n equals factorial of n equal factorial of 3 equals 6. Then we have n minus 2 equals factorial of 3 minus 2 equals factorial of 1. This is 1. Okay, and we have here n factorial of 3 minus n equals 3 factorial of 0. This is equals 3. Okay, in this case, in case we have 3, 6, 1, 3 is the lengths of the sides of this triangle, but here this side is refused. Okay, these lengths are refused. Okay, as 1 plus 3 is not greater than 6. Okay, then these 3 lenses are not representing the lenses of side of triangle, then we have the answer is perimeter k equals 5 when n equals 2. We have another example. If half factor of n and factor of n minus 3 and n factor of 3 minus n are the lenses of a triangle sides, find the perimeter. Okay, as we have the length of one side is n minus 3 from the properties of factorial, then we have n minus 3 is greater than or equal to 0, then n is greater than or equal to 3. Okay, from this side n factor of 3 minus n, then 3 minus n is greater than or equal to 0. Okay, then we have here n is less than or equal to 3, then from these two relations we have n equals 3. Okay, then we have the sides lenses. Okay, we have here half factor of n equals half factor of 3, this is equal 3. Okay, and we have factor of n minus 3 equals factorial of 3 minus 3 equals factorial of 0 equals 1. We have here also n factorial of 3 minus n, this is equal 3, factorial of 3 minus 3, this is equal 3. Then the lenses of these sides equals 3 1 3. Okay, then the perimeter equal 7 units. Okay, and you have to check that the sum of the lenses of any two sides of this triangle is greater than the length of the third one. Here we have another example. If half factor of n and the factor of n minus 2 and factor of 2 minus n are lenses of a triangle sides, find the area of this triangle. Okay, here we have, as we explained before, factorial of n minus 2 is the length of one side of this triangle. Then from the properties of the factorial, we have n minus 2 is greater than or equal to 0, then n is greater than or equal to 2. Okay, from this one we have also n 2 minus n, k is one side length. Then we have from the properties of factorial 2 minus n greater than or equal to 0, then n is less than or equal to 2. Then from these two relations we have n equals 2. Okay, then we have lenses of these sides. Okay, we have half factorial of 2 equals 1. Okay, and we have factorial of n minus 2 equals factorial of 0 equals 1. Okay, we have the third length is factor of 2 minus n, then factorial of 2 minus 2 equals 1 as well. Then we have here the three sides are equal, then we have an equilateral triangle. Okay, for example this triangle. Okay, then we have this side length is 1 and this one and this one, and this angle is 60 and this 60 and this 60 as well. Then here we can find the area of this triangle equals half base height. Okay, then we have half base is 1, this one, and height this one, h. Okay, h here equals 1 sine 60. Okay, then the area equals root 3 over 4 square unit, and this is required to find. We have this example. If 30 factorial of x equals factorial of x plus 2, find the value of x. Okay, here we have 30 factorial of x equals factorial of x plus 2. We can express this as x plus 2, okay, times x plus 1 factorial of x. This is equal 30 factorial of x. Then we cancel this with this one. Then we have here x plus 2 times x minus plus 1 equals 3 0. Okay, here we have two methods to solve this one. We can consider 30 equals 6 times 5. Okay, here we have x plus 2, okay, equals 6. Then we have x equals 4, or we have x plus 1 equals 5. Okay, then we have also x equals 4, and this is required to find. Okay, we can use a normal way. We can multiply these two brackets, then we have x squared plus 3x plus 2, okay, equals 3 0. Then we have x2 plus 3x minus 2 8 equals 0. By factorization, we can find this x minus 4, and we have here x plus 7 equals 0. Then from this bracket, x minus 4 equals 0. Then we have x equals 4, and this is acceptable. Okay, here we have this from this one, x plus 7 equals 0. Okay, then we have x equals negative 0, and this is does not belong to the positive z. Okay, as this as from one of the properties of the factorial, x must be included in z positive. Okay, and this is not the case in this time. Then we have x equals negative 7 is refused. Then the final answer or solution is x equals 4, and this is required to find. We have this example, if 1 over factorial of n plus 1 over factorial of n plus 1 equals 9 over factorial n plus 2. Okay, find the value of n. Here we can express this relation as 1 over factorial of n plus here 1 over n plus 1 factorial of n, okay, equals 9 divided by n plus 2 times n plus 1 factorial of n. Then we'll cancel all these terms. Then we have 1 plus 1 over n plus 1 equals 9 over n plus 2 times n plus 1. Okay, here we can take n plus 1 as common denominator. Then we have here n plus 1 plus 1, okay, equals 9 divided by n plus 2 times n plus 1. Then this one will cancel with this one. Then we have here n plus 2 equals 9 divided by n plus 2. Then we have n plus 2 square equals 9. Then we have n plus 2 equals positive negative 3. Okay, then here we have n plus 2 equals 3. Then n equals 1, or n plus 2 equals negative 3. Then we have here n equals negative 5. Okay, n equals 1 is acceptable as it's included in z positive. Okay, this not included in z positive. Okay, then the final answer is n equal 1, and n equals negative 5 is refused, and this is required to find. Here we have this example, if factorial of n plus 1 over factorial of n plus 2 plus factorial of n divided by factorial of n plus 1 equals 13 over 42. Find the value of n. Okay, we can express this relation as factorial of n plus 1 divided by, this one is n plus 2, okay, factorial of n plus 1, plus here we have factorial of n divided by n plus 1 factorial of n. This is equal 13 over 42. Okay, then here we have 1 over n plus 2 plus 1 over n plus 1, this one equals 1 3 divided by 4 2. Okay, then we can here n plus 2, okay, multiplied by n plus 1. Here we have n plus 1 plus n plus 2 equals 1 3 over 4 2. Okay, here we have n plus 2, okay, times n plus 1, and we have here 2n plus 3. Okay, this is equals 1 3 over 42. Okay, here we can multiply. Then here we have 1 3 n square plus 39n plus 26 equals 84n plus 126. Okay, then we have 1 3 n square minus 45n minus 100 equals 0. By factorization, we can find n minus 5 times 13n plus 20 equals 0. From first bracket here, from this one, n minus 5 equals 0. Then we have n equals 5, and this is acceptable. From second bracket we have 13n plus 20 equals 0. Then n equals negative 20 over 13, and this is refused. Okay, as it's not included in z positive. Then the final answer or solution is n equals 5, and this is required to find. Now it's time to check your understanding by trying to solve the following two problems. Find the value of 1 times 3 times 5 times 7 times 9 times 2 power 5 times factorial of 5. Okay, the answer is factorial of 10. Okay, second one is find the general form of the following relation or the following statement. Factorial of 1 plus factorial of plus 2 factorial of 2 plus 3 factorial of 3 plus and so on 10 plus n factorial of n. You have to find the general form of this expression and check when n equals 5. Okay, the answer is the general form of this expression is factorial of n plus 1 minus 1. When n equals 5, then the result is 719. You have to solve these two problems in details.